Hello guys, welcome to the Tech Engineers Academy. So today we are here to discuss the next topic on Linux device driver. So earlier what we have discussed is tasklets. So how we can write the tasklets in Linux device driver. So today we will go further in this Linux device driver. So today we will discuss the Spinlocks, how we can write the Spinlocks here. There are different methods: static, dynamic method. There will be read write Spinlocks too. So how before that we will try to write the kernel threads. We will try to understand what are the kernel threads and how we can write the kernel level threads. So what is the difference between user level thread and the kernel level thread? And most probably, as earlier we have discussed, like we will try to include Spinlocks in the tasklet function. So we'll try that too in this video. So let's get started. So we have discussed all this interrupt handling and all these functions, and moreover the bottom halves in that we have discussed the tasklet and how we can declare the tasklet and how we can schedule it. So today so we'll start from thread, and so thread is an independent flow of control that operates within the same address space. So what it means like in a single process, so you can have a multiple threads, so with each thread executing different code concurrently while sharing data and synchronization much more easily than the cooperating processes. So in a thread, so you can have a communication better than the process. So to switch between the instruction on the parallel thread, execution states needs to be saved. The means is it's just a program counter or and a CPU register. So it will tell you the what instruction to the execute next. So in thread, like you just have to handle like a CPU can handle one instruction in time. So you need to go through the threads and all to take care of this communication and all. And management includes saving that states, some restoring states, and deciding which thread to pick next. So it is taking care by the management and whatever the threads we need to take. And there are two types of threads. The user level thread, which we are writing in a user space application, where we are writing where we are using pthread create to create the thread. We are using the calls like pthread underscore join to just to wait to complete the particular thread and come back to the main function, so that it can release and continue the other thing. And in a kernel level thread, which we are using in a kernel programming on Linux device driver programming. So in kernel level, the kernel level thread are managed by the OS, and the function involved in the kernel threads are kernel kthread create, wake up process, kthread stop, kthread should stop, and kthread point, and kthread run. So kthread underscore create is basically used for creating the kernel thread, in which we are passing the argument as a thread function, the data pointer, and the string, the name of that kernel thread. Wake underscore up underscore process is used for starting the kernel thread. So basically we can use kthread create and the wake up process to do the further communication. Kthread stop will help you to stop the kernel thread, and there will be another functions kthread should stop, and which will check that your kernel thread is stopped or not. So it will be woken, and this will return true when whenever someone calls kthread stop underscore stop. And there is some other method also to create the kernel thread. So we don't need to write kthread underscore create and after that wake up process. So in spite of that, we can use kthread underscore run to create, as well as it will start the kernel thread too. So we'll try to include in our code. So what we'll do, so first we'll have the like now we have the basic understanding of thread, like how thread is working in a particular address space and all. So now we will write some piece of code to better understanding for that. So let's go to the terminal. Sudo su yep. Yes. So now what we will do first, we will use the kthread underscore create to create the kernel thread, and later on we will shift to the kthread underscore run. So first we will include some of the header files. Linux/kthread.h for creating the kernel thread, and we will use some sleep, so we will use Linux/header Linux/delay.h header file. So now the first thing, we will create the structure which is the return type when we will create the kernel thread by using kthread underscore create call. So we can write the structure here: static struct task underscore struct star chr underscore thread. Yeah, so this is our function. So now what we will do here, so we will create the thread and we'll go to the init function. Yeah, chr underscore thread is our return function. Kthread, it's a structure. Chr underscore thread is a structure. First we will pass the function thread function wall. We'll write the prototype and the function body later. We'll pass null as a pointer, data pointer, and we'll write a character thread. Nice. So if chr underscore thread, so we will start the kernel thread by writing wake up process call. Yep. We will close this, else unable to create the thread. Go to r underscore device. It will destroy the class. Okay, so to stop that, we will write kthread underscore stop chr underscore thread. So now what we will do, we will write a function here, int thread underscore function. So I just need to check what I have written. Yeah, function 1. Yeah, I'll pass as a pointer, void pointer. Yeah, int I equals to 0, while here we will use kthread should stop just to check our thread is stopped or not, and it will return the value. In our kernel thread function, I'm just increment some value over here, and we can use some sleep here, and we can return 0. So we can write the prototype also. So great. So we have successfully created the function, and after that we have written the kthread underscore create to create the thread and the wake up process to start the kernel thread. So everything is good to go. So we can write make here. Great. So we can now insert the module message. Okay, so you can see here like device driver insert after that in our kernel thread function. So I'm just incrementing some variable and putting some sleep over there, so it is incrementing. So in this way we can write our kernel thread. So now there is another method too. So how we can proceed into that? So we can use kthread underscore run too. So to do that, what I will do here, so I'll just commit it down the kthread underscore create yeah. So here we can use the same call, same structure, chr underscore thread. So kthread underscore run. So you can see the difference here. So now I'm just printing the value, printing the string that successfully created that kernel thread, because the kthread underscore run has done both the functions that kthread underscore create and the wake up process was doing. So good to go. So we have written the kthread underscore run function. So now we can do make. Message -c, inserting the module, the message. As you can see here, we have successfully created the kernel thread, and we can now remove that. Yep. So now in this way we can use the kernel thread. So now the next thing is Spinlock. So what are Spinlocks? So Spinlock is you have seen in the user space programming in the application, like the semaphores like kind of thing. So if there are multiple processes and are running, so if one process is running, other has to wait for that. So they are the other processes keep on checking that the process is completed or not. And so the Spinlocks we are using in a thread, in a kernel. So the Spinlock is a very simple single holder lock. If a process attempts to acquire a Spinlock and it is unavailable, the process will keep trying, means it's spinning over there until it can acquire the lock. This simplicity creates a small and a fast lock. There are two possible states in Spinlocks, locked or unlocked. So we can initialize the Spinlock in two ways. One is a static method, which we can use define underscore Spinlock, and we can pass the structure over there. And the dynamic method, the Spinlock underscore test underscore Spinlock, and the initialization of that Spinlock. The functions used in the Spinlock is spin underscore lock, try lock, unlock, and spin is locked or not. So it's just similar like how we are doing in a semaphore and all. So Spinlock is similar to that. So the difference between a mutex and Spinlock is Spinlock will not go into the sleep, but in a mutex will go to the sleep. So basically Spinlock we can use in a tasklet. So first what we will do here, we will try to write a simple test program just to test the Spinlocks over here. And later on we will jump into the tasklet. So how we can write the Spinlocks in a tasklet. So let's go to the terminal. So first we will use the static method. Define underscore Spinlock, and we'll pass a Spinlock here, ch underscore Spinlock. After that, what we will do here, we will create two functions here. First we will create a structure over here. So we will static struct task underscore struct, chr thread. Okay, so we have views in a kernel thread. So what we can do here, one sec. We can use like that. Yep. So now first we will create the Spinlock. So now in an init function we have written kthread create and kthread run. So what we will do here, one will use by thread underscore function 1 and other is used by thread underscore function 2. Okay, so we have successfully created this kernel threads. So now we will go to the functions. This looks nice here. So spin is logged, we have used here. If it's not, like it'll enter and it'll say like Spinlock is not locked in the thread function 1. If it's there, then it'll go to the next function and it'll check. We will use here Spinlock. If it's not locked, it will come out and it will lock the Spinlock, lock the particular function thread by using spin underscore lock. So here again we are checking if this is logged, then it will print that Spinlock is logged in this particular thread. So what we can do here, so we can create some global variable here, just to increment some value and all. So unsigned long chr spinlock variable equals to 0. Great. So now we will increment chr underscore spinlock underscore variable plus plus. Great. Thread function first percentage u chr spinlock underscore variable. Great. And after that we will just unlock the spinlock by using spin underscore unlock. And we can use here some sleep too. And after that we can return 0 to this. Great. So now we can write some other function too. Thread underscore function 2 void pointer. Yeah. Thread function 2 while of key not of key thread should. So what we can do here, so we can use the same API here. 1 2 3 4 5 6. Yep. Two. Two. 1. This we can make it 2. We'll return 0 here. So we will just change here 1. Sorry. Kthread underscore stop chr thread 2. Yep. I will change some values. 1 1 2 2 1 2 1 here. So it's good to go. So we have covered each and everything. Let's see. Make. Oops. 1 sec. One sec. Yep. Spin underscore unlock 77. Just 1 sec. So it's good to go. Yeah. So everything is goes well. So now we will just insert our module. That's it. So Spinlock is not logged in thread function 1. After that, we came out, we logged the thread function. That enters into that, and it shows that Spinlock is logged in the thread function 1, as you can see here. And after that, it is printing in thread function 1. After that, again, it's like successfully creating the kernel thread, and your device driver inserted successfully, and after that it shifted the kernel thread to, Spinlock 2. After that, again, it is taking the value and printing it. So as you can see here, so it's a proper communication. So proper, like so if a particular process is there, so it's firing a lock, so it will lock, it will do the whatever the work you need to do. I'm just increment some variables, so if you need to do some more work, so you can do here. So in this way you can use Spinlocks here. So now as I just want to explain you how we can use these things in our tasklet. So if we want to use this in a tasklets, like as in a IRQ handler and the bottom half, so there's another call that is nothing but a spin underscore log underscore IRQ. So how we can use that? Okay, make clean vi sketcha. Okay, 1 sec. Yes. So now how we can use this in our IRQ handler and the tasklet function. So we can use here spin underscore lock underscore IRQ, address of your Spinlock. Okay, after that you can just if you want to, if you can just increase the value whatever the variable you have declared. So this I will just declare it upside. That's it. Okay, interrupt occurred and executing ISR routine, so we can display our value here. Pretty much good. And after that we can just unlock this IRQ, address of CHR underscore Spinlock. Great. So here we can just make a note here, scheduling the tasklet. Okay, so it will go to the tasklet function. So now what we need to write it here, spin. So same thing we can use here. Okay, that's it. And after that we can just unlock this. Okay, so we can just uncomment this. We can just uncomment this one also. Okay, so we are using in a dynamic way, so we can comment it down this one. And we need to uncomment the free IRQ and the tasklet. So good to go. Yep. Oops. Wait a second. What happened? Maybe okay. This will be the issue, maybe. Yeah. So I think so. This time I will not come. Yeah, great. So now we have successfully done this using the Spinlocks and the tasklet. So what we will do, we'll just we'll just insert the module. So now we'll just see the logs. Okay, so executing the tasklet function, interrupt occur and executing the ISR routine. Okay, so in this way spell is not logged. So in this way you can write the spell logs in the tasklet functions. So you can there is different method. You can write it down a tasklet function, and from the tasklet function you can call the threads and all. So there are multiple things you can try it out. So in this way, so we have successfully completed the using of Spinlock in a kernel threads. So now what we will do here, so there will be another method of how we can write and read the Spinlock by using read and write calls. That we will discuss in the later sessions. So if you like this video, please don't forget to like, share and subscribe. And most probably, like later on, we will just jump into the memory management, how we can handle the memory, how we can fetch the virtual address, how can we see and we can do the operations on that memory management, and we will see into that. And we'll go to the atomic operations, how we can use mutex, how we can write down the work queues, the another bottom halves. So there will be a multiple things. So step by step we'll go to the advanced Linux device driver programming. So till that, subscribe to this channel and keep me posted if you have any issues. Thank you so much.